And scholars, as promised, we are back at it again. We are continuing lesson 4, and this will be the activities where we get some practice in. Now, the activity that we are going to be doing is a true and false. So, when we do these true and false, we need to be able to defend our reasoning with an example. We need to be drawing pictures and describing why our answer, true or false, is correct. We're using attributes to classify these shapes, okay? So we want to make sure that our pictures are labeled and very descriptive. So there is no question about where we stand. Because sometimes when we draw a photo, we're like, are they trying to say this? Or are they trying to say that? What are they? We do not want any question. So let's begin. True or false? All trapezoids are quadrilaterals. Okay, well, let's begin. I'm a very word person. I like rules. So let's begin with the rules. The rules for a trapezoid are, I spelled that one wrong. The first rule for a trapezoid is that you must spell me correctly. Okay. And then after you spell it correctly, it must have 4 sides. And, oh, there we go. And at least one pair of parallel sides. Okay, so that's the rule. And we can see, just looking at this rule, it says it has to have 4 sides. That automatically makes it a quadrilateral. Because remember, a quadrilateral is any shape that has 4 sides. So we can see easily from the definition alone that every trapezoid has to be a quadrilateral. So let's put true. But remember how we said that there is no one right way to be a trapezoid. Let's draw some examples of what a trapezoid is. And remember, a trapezoid can look like various different things. As long as it follows these 2 rules of 4 sides and at least one pair of parallel sides, it's a trapezoid. So here we have a drawn photo. We have 2 different trapezoids, but remember, I just said that there's no one right way to be a trapezoid. As long as it has the 4 sides and at least one pair of parallel sides, it's a trapezoid. So to be a trapezoid, it has to have 4 sides, meaning it must be a quadrilateral. Now, these are some of your basic forms of trapezoids that we might see. But if you go on Google photo for a trapezoid, look, there's so many different types. These are trapezoids right here because there's not one right way. As long as you fit those vague rules of 4 sides and at least one pair of parallel lines, it's in the trapezoid family. We could even draw the shape that we call a parallelogram. Because remember, it has 2 pairs of parallel sides. So it is a trapezoid and a parallelogram. But we also want to make sure that we can write out our answer. So take 30 seconds to articulate in your best words why all trapezoids are quadrilaterals. Afterwards, unpause the video. So here is our written out answer. We have all trapezoids are quadrilaterals because to meet all the requirements or rules of a trapezoid, and those rules are must have 4 sides and at least one pair of parallel sides, it naturally meets the requirements of a quadrilateral, which is a shape with 4 sides. So to support our answer, we have a picture and we have a use of definitions. So we have a well-rounded answer with valid evidence and support. Moving on to the next one. All quadrilaterals are trapezoids. True or false? Well, let's draw a kite and see what happens. Okay, so now I have my two pieces of evidence. I have my vocab words and I have a picture drawn. So here I am proving why I do not think quadrilaterals or all quadrilaterals are trapezoids. So just because a shape has four sides does not mean that it has at least one pair of parallel sides. For example, let's look at the kite. So the kite has 1, 2, 3, 4 sides. And line 1 and 2, they are congruent. They are adjacent to each other. But they are clearly not parallel because look, they intersect right there. And 4 and 3, the same story. They intersect right here. So they're not parallel. 4 and 2, they would eventually meet and cross down here if these lines continued. So they're not parallel, and the same for 1 and 3. They would eventually cross. So those lines are not parallel. So we can see here that it is a quadrilateral, and it does not have any parallel sides. So it's not a trapezoid. So this is an example of a quadrilateral with no parallel sides, and it's not a trapezoid. So here is our final answer. This kite is an example of a quadrilateral that does not have any parallel sides. Just because a shape has four sides does not mean it will be a trapezoid, which requires four sides and at least one pair of parallel sides. Let's scroll down to find the example of the quadrilateral hierarchy to see, look, this is another example of a quadrilateral that's not a trapezoid. These lines will eventually meet. Let's draw those out. These lines will eventually meet. Boom. These lines will eventually meet. Boom. Not a trapezoid, but it is a quadrilateral. See, 1, 2, 3, 4. Quadrilateral. All squares are trapezoids. True or false? Okay, take as long as you need, pause the video, and do this one on your own. And when you unpause the video, check to see if your answer is correct and if you have pretty valid evidence, if your evidence is convincing. Okay, here's my final answer that I got. I said true. So let's begin with my definition support. I said a trapezoid it has four sides and at least one pair of parallel sides. A square has four sides, it's a quadrilateral. At least one pair of parallel sides, it's also a trapezoid. Two pairs of parallel sides, a parallelogram. Opposite sides are congruent at four right angles. It meets the rules for a rectangle, and all sides are congruent, and it meets the rules for a rhombus. So I even drew some pictures here, and we can see that this trapezoid has four sides and only one pair of parallel lines. And we see this square here. Let's go back to these definitions. I see it has four sides. 1, 2, 3, 4. Quadrilateral, check. Okay, 1 and 3 are parallel, so it's a trapezoid. Oh, and 4 and 2 are also, so it's a parallelogram. Opposite sides are congruent. Yep, 1 and 3 are congruent. 4 and 2 are congruent. And there are four right angles. Oh, but now that I'm looking, not only are 1 and 3 congruent, but 1, 3, 4, and 2 are all congruent. So we can see that it fits all those rules. Now, here is my Here is my explanation. All squares are trapezoids because the rules for a square, quadrilateral, parallelogram, rectangle, and rhombus, which can be seen here, make sure we connect those, naturally meet the rules for a trapezoid, which are 4 sides and at least 1 pair of parallel sides. The square has the most rules and qualifications in the quadrilateral hierarchy. That's the most elite shape in the quadrilateral hierarchy because it has the most rules to follow. Look at all these rules it has to follow, but look at how vague the trapezoid is. The trapezoid just has to have 4 sides and at least 1 pair of parallel sides. Look at all the other annotations the square has. It's much busier. It has a lot more jobs to fit, a lot more jobs to do. Well, I didn't mean to do that. I'm sorry, y'all. Let's get that back. There we go. Okay, same thing with this one. Take as long as you need, fill it out, and when you're done, press play. Okay, we're going to walk through this one together. Again, let's begin with the definitions. We have our definitions here, or rather just bullet point qualifications that each shape must have. And we can see that the rectangle and square both have 4 sides. They're both quadrilaterals. They both have at least 1 pair of parallel sides, so they're both trapezoids. They're both parallelograms. They both have 2 pairs of parallel sides. And they both have opposite sides are congruent in 4 right angles, which makes them both rectangles. Excuse me. They both meet the qualifications for a rectangle. But only the square has all sides are congruent. Only the square has that. So here we have a picture of a rectangle and a square, and we can see this visual difference. You see how when we say opposite sides are congruent, so we see that's one length and then that's another length. But the sides are shorter. With the square, all sides are the same. All sides are congruent. So just based on that last factor alone, this last attribute, would it be possible for all rectangles to be squares? No. Because look, a square naturally meets all the rules for a rectangle. But a rectangle is missing that last attribute. So not all rectangles can be squares, but all squares can be rectangles because look, the square naturally meets all the rules for a rectangle. So here we go. The overall final answer, false. All rectangles are squares. That's a false. Because as we said before, it's missing that final attribute. Where is it? Let's go read the statement. Not all rectangles are squares. Only some squares are rectangles. I apologize, there was a typo there, so we got that corrected. So not all rectangles are squares. Only some rectangles are squares. The sum is what we're looking for. So rectangles are missing the final attribute that a square has, which is all sides are congruent. Yet all squares are rectangles because squares naturally meet all the requirements for a rectangle. All squares are rectangles, but not all rectangles are squares. So here's this photo. We can see in this the squares inside the rectangle. So all the squares are going to be rectangles. But only some rectangles are going to be squares. Here, look at this. So all squares, look, they naturally meet all, those are all the rules for a rectangle, which a square naturally has, and it has an extra one. And that extra one is what the rectangle doesn't have. But if the rectangle does have that final attribute, then it's going to be a square. And look, that goes in with the idea. It's like a cycle. It's a continuous cycle. That if that square is a rectangle, because look, we do consider the square part of the rectangle family. So to finalize, all squares are rectangles, but not all rectangles are squares, only sometimes. This is our last one, scholars. So kites are never rhombuses. This one is a really tricky one to explain and also understand. But through persistence and practice, I know that we will be able to get this. So try to think about this for a bit. Try to think, does a kite, is it possible for a kite to be a rhombus? And is it possible for a rhombus to be a kite? So let's just start with the vocab or the rules. So a kite is a quadrilateral and it has two pairs of congruent sides that are adjacent. So that's the rule that a shape must follow to be in the kite family or to be classified as a kite. And for a shape to be classified as a rhombus, it needs to be quadrilateral, four sides, trapezoid, at least one pair of parallel sides, parallelogram, two pairs of parallel sides, and finally the rhombus attribute, all sides are congruent. So based on that definition alone, we can see or we can understand or try to comprehend that we know that a rhombus can be a kite, but it's kind of hard to think about. We need to draw it out to truly understand. So let's go do that. Okay, so here we have our typical kite picture that we have been using for this video. And remember, a kite is a vague description. It's like a trapezoid. There's no one right way for a kite to look. As long as it follows these rules of being a quadrilateral that has two pairs of congruent sides that are adjacent, it is a kite. So it's a vague description, so it can have many different forms. But a rhombus, remember, all sides must be congruent, two pairs of parallel lines, and four sides. So we know the rhombus is part of the quadrilateral, trapezoid, parallelogram, and rhombus family. But the kite is only part of the quadrilateral and kite family. So let's look. Based on this image and the the rules and definitions that we have on the left, is it possible for a rhombus to be a kite? Well, remember, I'm going to take y'all way back. Do y'all remember on the first lesson where we asked, well, maybe it was the second. Yeah, okay. We'll say the first or second lesson where we asked, does the orientation of a shape affect its attributes? We said no, because the attributes stay the same whether or not you put a rectangle on its side or lay it flat. So here, I'm going to move the rhombus and see if that helps the way we see it. So look, it's the same rhombus. I just rotated it. I just changed the orientation. But look, all the attributes are the same. All sides are still congruent. There's still four sides, and there are two parallel lines. But this helps us compare it, apples to this kite. And when we put it like this, we can see, oh, a rhombus? It's not that different from a kite when you put it like that. But let's see if it fits the rules for a kite. So it has four sides, so we already know that it has a quadrilateral rule. Check. But does it have two pairs of adjacent lines that are congruent? For the kite, we see that 1 and 4 are adjacent and congruent, and 3 and 2. So 4 plus 1, 3 plus 2. What about the rhombus? Well, yeah, 1 and 4 are adjacent and they're congruent. 1 and 2, excuse me. 1 and 2 are adjacent and congruent, and then 4 and 3. Here, I renumbered the kite and the rhombus that way that they're the same. Because you'll notice it goes 1, 2, 3, 4, 1, 2, 3, 4, and a clockwise rotation. So now we can see on the kite, 1 and 2 are adjacent and congruent, and 4 and 3 are adjacent and congruent. Now we're going over to the rhombus. 1 and 2, adjacent congruent. 4 and 3, adjacent and congruent. So this kite fits the rule for a rhombus. Excuse me. This, do not write that down. It's been a long day and it is only 7 a.m., y'all. So this rhombus fits the description for the kite. So it's a rhombus and a kite because it meets that description of 4 sides. It has 2 pairs of congruent sides that are adjacent. But does this kite fit the rules for a rhombus? Well, okay, let's be at 4 sides, check, and now it needs to be a trapezoid. Okay, it didn't even make it past a trapezoid side because, look, there are no parallel sides in this kite. But remember, we just said that this shape right here was a rhombus and a kite. So since it is a kite, this would be an example of a kite that's in the rhombus family. So the way we need to phrase it is that it's false. Kites are never rhombuses. We just proved it. This rhombus is a kite and it's a rhombus. We just said it's a rhombus and a kite. So sometimes kites are sometimes rhombuses. I'm going to spend the next 30 seconds writing and articulating why up here. You should do the same and compare your answer to mine. Press play when you're done. So here is my final articulated answer. Kites are sometimes rhombuses because the shape needs to meet all the qualifications of a rhombus, which are quadrilateral, trapezoid, parallelogram, and all congruent sides. All rhombuses are kites because they naturally meet the rules and qualifications of a kite, which are just quadrilateral and 2 pairs of congruent sides that are adjacent. Because of this, all rhombuses are kites, but only some kites are rhombuses. And scholars, don't forget, adjacent means next to. So, to top it all off and wrap it up, all rhombuses are kites, but only some rhombuses. All rhombuses are kites, but only some kites are rhombuses. You want to make sure you end on a good note there. And remember, the orientation of a shape does not affect its attributes. We can see that here with what we did with the rhombus. We turned it to help us compare it with this kite. So the key takeaways on this slide are that a kite is a vague description, and like a trapezoid, there's not one right way for a kite to look. Because of its vague description, a kite can come in many different forms. 2, orientation of a shape does not affect its attributes. 3, all rhombuses are kites, but only some kites are rhombuses. All right, y'all, good job, and get ready for lesson 7 because that's when we bring in triangles. Y'all have a good day.